Alright, so it's been much overdue, but I finally got an axle shaft. Unfortunately, it's only one at this time, but this is from a 2001 Boxster S. This is the heavier duty of the two axle shafts offered by them. So the good news is, at this point, this is the side that bolts right up to the Boxster S transaxle. Bolts right on there, there's no issues to it. Over here, however, this is made for the Boxster spindle, and there's probably not a real good chance this is going to fit the NA hub of all from the Toyota. So at this point, my options are, what I've been milling over in my head is separate this at the junction and make the actual hub end from a turbo MR2 fit this axle shaft. It's going to have to go to drive shaft shop. The problem with that is every time I break an axle, it's going to be a custom replacement, so it's going to be difficult. My other option, so might be easier in the long run, is to switch out the hubs, remove the Toyota hubs, install the Boxster S hubs, which is going to be some awesome machine work, and see where that gets me. So before we do anything, might as well just give it a try and see if we're anywhere near fitting the Toyota hub. Alright, and just to say we tried, just give this a shot and see. Not a chance. This thing's quite a bit bigger. So like we figured, I'm going to start by pulling this hub off of here, and we'll see if we can manage getting a Boxster S spindle or a hub. Alright, so I recently just got these hubs pulled out of the old knuckles from the MR2, and this is the Boxster S hub. And I haven't pulled it out of here yet because when I got this, I'm starting to look at these two things and I'm realizing they're quite similar. And my favorite part is, this weighs next to nothing, maybe 20 pounds, and this cast iron one is at least 40. So that got me thinking, why am I going to put this heavy thing on here? The other issue I'm looking at, it's not a big issue, if I were to get this hub pressed into here, there's a lot of material around here that this needs to recess into, and the actual face of this axle will not go through here. So that's a lot of machining, and that may weaken it to where I don't even want to use it. So what options do I have? Well, why don't I try this? Can't guarantee it'll work, but it's at least worth trying. So to get this on here, to look at the differences, the glaring difference is this has a bolt-on ball joint, and it's at the center of the actual axle shaft. You can see it goes straight through the hole. This one, unfortunately, is set forward, so it's going towards the front of the car. I'll flip it around. This one is set rearward towards the rear of the car. And I can't use the lower control arm from that unless I make one, or I can go back to the junkyard and get more things. So I did. So now I have, this is the Boxster S lower control arm, and the other difference we have is bolt-on strut, slide-through strut. So I've also got the strut assembly that goes with the Boxster. Not much difference as overall length goes. It slides through the top of there, bolts go through it. The huge difference is the top. This has this really depressed look to it, where it mounts below the top of the shaft, which won't fit in that car. And you compare the Toyota one to it, overall length's about the same, which is good. This fits in the car, this fits, the overall spring's a little wider, but it still fits in the cavity. This is the difference. So if you ever seen a lift kit for some of these newer trucks, so it just pushes the suspension down, they build a cage. It bolts to these 3 bolts, the cage comes up. There's a new mounting position which is going to mimic these. So I'm going to have to build a cage. But before we go ahead and do all that, I'm going to mock up this suspension on that car just to see where we're at and if it's even worth doing. So I'm going to get going on that. Alright, here's where we're at. So the knuckle's in there. The drive shaft is connected to the transaxle. It's giving me the right measurement for outwards. And the strut fits, but I just gotta make a little bit of clearance room if I'm gonna use the Porsche strut and make that tower on the top of it to fit. And it's centered. It's just a little higher than where it used to be. That may work out to my advantage. Pretty much what we were expecting. This is a lower control arm, and you can see it's about 2 inches off, maybe more than that, from where my mounts are. Additionally, this control arm has no adjustability, and it won't give me any adjustment for camber, so probably gonna have to make one. Not really a big deal, but I think that's the route I'm gonna go. So I'm gonna get an adjustable Heim end on that side, box steel tube, and then I'm going to put a ball joint on the end of it. That should give me some adjustability. So while I'm also here, I think I'm going to slice off the bottom end of my my Toyota strut, just so I can fit it in the Porsche knuckle. And then for the front adjustment, this is the basic MR2 one. It goes through the control arm. I am going to remake the new one, if you can see it in here, like that hole upwards, and I'm going to basically make the ladder arm off the Porsche. So it's going to be this. I'm going to have to shorten it, and it's going to be just an opening that goes over here and bolts through, and then the threaded section of this will give me my adjustability. So it looks like I got to make a lot of things. I do think this is going to fit though, and let me show you with the wheel on it. All right, here's the wheel on here. This is this shorter version of the Porsche wheel. It just fits the knuckle. I got some more room on the outside to go wider. And I have, see where the strut's supposed to go in that knuckle. Imagine that going up, I'm still gonna have another inch or two to go wider there also. So at least I know I have some room to work with. So actually at this point, nothing's bolted up, it's just only to the axle, just to give me the right space. So at this point, modify strut towers and make a lower control arm. All right, on to making the lower control arm. So as I mentioned, this is the Porsche unit. It kind of works, but it's about an inch too short. I'll leave the measurements out of it. So I'm going to use this as a base structure. This is a 1x3 1/8 inch steel tube, or steel square tubing. That's going to be the main structure. So for the rod end on over here, this is a 3/4 inch Heim joint, so that's going to cover this portion. Luckily enough, this will be what gives me some adjustability for some camber. What goes inside the Heim joint are misalignment spacers, so they'll go in here. So this will basically cover that, allow me to bolt it to the car where I've had it originally. The Porsche unit has this size of a ball joint. So after shopping around a bunch of different auto part stores, I come up with this. This is a GM unit. There's the part number for it, DWK6696. It's very similar. It has the same pitch and diameters on it. It is a little longer on the top end, but just the shimmer tool will take care of that. To make this work in the steel tube, I got a chromoly steel tube with a relatively close inner diameter. I do have to hog it out some. So it's going to get buried in there. And that'll cover the ball joint end. So a big hole for that. And big Heim joint on the far side. So the Porsche uses this as a drag link or a trailing arm. I tried to find this particular grommet and you couldn't find it anywhere. So I'm going to go with just a smaller unit of a Heim joint. This is going to get bolted on the inside of this. And then we'll work the length back to the car. So let's get that done. And just like that, there it is. Not fully welded together yet, but you can see the idea. I had to do kind of a lot of manipulation to meet this end. So if you want to see the full video of me building this, and it'll be up on the top corner up here, I'll put a link to it. So at this point in time, I have not welded the corners yet. You can see where I have to seam it together. I have to weld all the way around here yet. But it is together, and it'll get me something to start with. So at this point, I'm going to finish welding this, and then I'm going to get it set up onto the car, and that way I can get my measurements for my drag length or my trailing arms. We're going to do a quick comparison between the steel knuckle from the Toyota and the aluminum knuckle from the Porsche. We want to see what kind of weight savings we're going to get out of it. Start with the steel version from the Toyota, giving me 21.2 pounds. And the aluminum Porsche, 16 pounds even. So that gives me a 5-pound weight savings of unsprung weight per wheel. So let's hope that's worth it. All right, I got this thing put together. I had a quick coat of paint put on it, but just so you can see how this compares to the original version. The changes I had to make were basically just the end ball joint. So most of this fabrication was to get this style ball joint on to fit the Porsche knuckle. The other difference I ran into was the adjustable trail arm, and that does have a Heim on the inside. So it gives me this extra bit of flexibility here. Depending on how this reacts on the street, I might change that flexible Heim out to a solid rod end link. So may make a difference, it may not. So the next thing we're going to do is get this thing put on the car. And then just before we do that, I want to do a weight comparison between the new ones and the cast iron ones from Toyota. All right, first let's weigh the Toyota version. It's 8.2 pounds. And we'll compare that to the thing that I made at 6 pounds even. So it's giving me 2.2 pounds of weight savings per wheel on unsprung weight. Not including brakes yet. Alright, so here we are with the suspension just loosely put together. And there we have the lower ball joint connected to the knuckle. We have the trailing arm connected to the subframe. We have the axle in place. And over here, we have the control arm bolted to the subframe. So the other issue we have staring us in the face is toe arm adjustment. And we have to address the new brakes, wheels, and I also have some changes we need to make to that strut until we can get coilovers. And in the meantime, I'm going to cut this video short, so next time we'll address those different issues. So in the meantime, thanks for watching. We'll see you next time.